Okay, number 16, yet another problem where we need to use whichever method we desire, elimination, substitution, or graphing, in order to determine if this this linear system has one solution, no solution, or many solutions. Okay, so we have 3x plus y equals 12, and 2y equals 6x plus 24. I'm going to go with the elimination method, because it doesn't matter. You'll get the same answer no matter what, right? You learned that in your projects. So we know that we need x and y on the same side. This one has x and y on the same side, the number's on the other side. This one's good to go. This one has y on the left side like we need it, but the x is on the other side. We need it over here. So we're just going to minus 6x here. And we'll have to also minus 6x here. So what do we get? Minus 6x plus 2y. That's what we have here. Alright, and on this side, the minus 6x goes away because we have a plus 6x and a minus 6x. We're left with 24. So we have minus 6x plus 2y equals 24, and then this top equation, 3x plus y equals 12. Well, we need to choose either the x or the y to make sure that they have the same coefficient with opposite signs. I like that the x already has opposite signs, so I'm going to choose the top equation. I'm going to multiply it by 2. So 2 times 3x plus y equals 12. I'm going to multiply everything in here by 2. And why? Because this one has minus 6x, and this one has a positive 3x. If I multiply by 2 to this whole equation, this x term is going to go to 6x. And when I add straight down, the x's will go away. Let's look. Let's multiply 2 by this top equation. So it becomes 2 times 3x becomes 6x. 2 times y, that's 2y. 2 times 12, that's 24. Alright, let's see if it works. Minus 6 and a positive 6x. Perfect, that's exactly what we wanted it to do. The x is canceled. Okay, 2y plus 2y, that's 4y. 24 plus 24, well, that's 48. We're going to divide both sides by 4 because 4 is multiplied by y. Okay, 4 divided by 4 is 1. 48 divided by 4 is 12. So we know that y is 12. We need to use that number to plug back into one of these equations to find x. I'm going to do the top one because I scribbled on it less. So knowing y is 12, we're going to plug 12 in right there. So 3x plus, here's the substitution, 12 equals 12. Okay, well, I want x by itself. So what I'm going to do is subtract a 12 here. So that goes away. So we have 3x equals, what is 12 minus 12? 0. If I divide both sides by 3 to get x by itself, 3 divided by 3 is 1. We're left with x. 0 divided by any number that's not 0 is going to be 0. So x is 0. X is 0, y is 12. And that is the one solution. Alright, last one like this, 17. We need to find if it has one solution, no solution, or many solutions. We can use any method we want. Elimination, graphing, or substitution. I'm starting to kind of see that in these equations we've been given, they look pretty similar. So I'm going to rearrange them and see if maybe they might be the same. So this is a technique we would use for any of the methods, rearranging them to make them look the same. So we could rearrange them to look like y y equals mx plus b. Or we could try to get the x's and y's on the same side with the numbers on the other side. It's up to you. I'll do both. Okay, so this one's already solved for y. I'm going to solve this top one for y. We have 3x minus y equals 5. Okay, well I have a 3x over here that I want to be over here because we're solving for y. So we're going to subtract 3x because it's added here. See? So subtract 3x minus 3x to this side also. That goes away. Leaves us with negative y. This is a negative 3x and a positive 5. I'm going to write it in this order so that it looks more like this. Alright? We need to divide this by negative 1 because we want a positive y by itself. Whatever we do to this side, we have to do to this entire side. So this just becomes y. Negative 3x divided by negative 1 is a positive 3x. 5 divided by negative 1 is a negative 5. Okay, so our top equation just became y equals 3x minus 5. Well, that's exactly what that second equation was. And when you have two lines, if here's a line, and I say draw another line and it's exactly the same one, that means that every single point it's going to have in common, which means every single point on that line is a solution to the other equation. They are the same line, therefore there are many solutions. That was number 17. Okay, now we're looking at number 18. This is a word problem that we're going to use system of equations and our techniques that we know in order to solve it. Alright, so Luke has $5 more than Sam. So it looks like we've got Luke and Sam. So I'm going to let Luke's money equal X. And it looks like we're going to be talking about Sam's money also, because Luke has $5 more than Sam. So we're going to let Sam's money, oops, okay, so we've got Luke's money being X, Sam's money being Y. Okay, let's continue reading. Luke has $5 more than Sam. Together they have $73. How much does each have? Okay, we have this first sentence. Luke has $5 more than Sam. Let's think of a way to write that where we relate X to Y. So Luke has $5 more than Sam. So the amount of Luke's money is 5 more than the amount of Sam's money. So Luke's money, I'm going to write it just like I just said it. Luke's money, X, is $5 more than Sam's money. So if Sam had $6, that means Luke would have 5 more than that. You add 5 to it. You would get 11. Alright, but we don't know how much it is. Let's look at the second one. We've got this first equation. So together they have $73. So that means together, so if you added Luke's money and Sam's money together, you would get $73. So let's write that. X plus Y equals $73. Alright, so we have two equations. At this point, you can use graphing, substitution, or elimination to figure out what each amount is. I'm going to use the chunk method because this one is already solved for X. Alright, that's our chunk. So plugging this in for X here, let's rewrite it. Instead of X, we're going to write 5 plus Y. That's our chunk. Alright, we'll continue writing. Plus Y equals 73. Alright, well 5 plus Y plus Y. We need to combine like terms. 5 plus, that's 2Y, equals 73. We need to get Y by itself. There's a 5 here that needs to go to this side so that Y is by itself. So we'll subtract 5, subtract 5. It's going to go away. We got 2Y equals 73 minus 5 is 68. We have a 2 multiplied by the Y. That's not okay. We need Y by itself. So we're going to divide both sides by 2. cancels. We're left with y equals, that's 34. Y equals 34. What does that mean? Oh yeah, we were doing a word problem, right? And we said y was Sam's money. So if y is 34, we're going to say Sam has $34. Okay? But he wasn't the only person we were talking about. We also had Luke. Well, if Sam has $34, what was that word problem? Luke has $5 more than Sam. So we take 34 and add 5 to it. We can also just use that equation if we wanted to. Alright, so Luke has, if Luke is x, right, equals 5 plus Sam, which is 34. And that gives us 39. So Luke has $39. Now if we get to this point and you're not feeling certain about your answer, how can you check it? You can check it by plugging them back into here. So Luke was x and Sam was y, right? So if we plug y, 34, here, and x, 39, here, we should get 73. Is 39 plus 34 73? It sure is. Okay, now we're looking at number 19. It says Lisa walked 8 kilometers more than Tim. So what are our two variables here? We've got Lisa and we've got Tim. So Lisa has got her distance. It's going to be some number of kilometers. We're going to call it x. Tim's distance that's going to be y. We've got x, we've got y. Alright? So Lisa walked 8 kilometers more than Tim. Alright, what does that say about Lisa's distance? Lisa's distance is x. So her distance is going to be equal to whatever Tim's distance is plus 8. So whatever his distance is plus 8. Alright? Let's read the next sentence. Lisa walked twice as far as Tim. What does that say about Lisa's distance? Lisa's distance is equal to whatever Tim's is times 2, because she walked twice as far as Tim. So 2 times y. Okay? I see a pretty good chunk here, so I'm going to use this as my chunk and plug it into this x here. So let's rewrite this top equation. In place of x, we're going to write 2y. 2y equals y plus 8. We need to have all the y's on the same side, so we're going to subtract a y here. Therefore, we have to subtract a y here. This is going to go away. 2y minus y is just y. All we have left here is 8. Y is 8. But what does that mean? Let's look back at the question. Why do we care that y is 8? Oh, 8, y, that's Tim's distance. So Tim, what did he do? Walk or run? He walked. Tim walked 8 kilometers. Okay? But he wasn't the only person walking. Lisa was walking too. And remember, Lisa walked 8 kilometers more than Tim. That was this equation. X equals y plus 8. Lisa is Tim's plus 8. So if Tim is 8, Lisa is going to be 8 plus 8. I got that from here. I plugged in the 8, the y equals 8 to here. So, oops. So she walked 16. So Lisa's distance, Lisa walked 16 kilometers. We can check that. Is 16, this x, is that twice as far as Tim? 16 double 8? It definitely is. And that's our answer.